For 75 years, Argonne National Laboratory has accelerated the science and technology that drive U.S. security and prosperity. To celebrate, we're capturing the stories of the people who've made it happen. This is Argonne Voices. 2012 was a big year in the world of physics. At the Large Hadron Collider in Geneva, Switzerland, scientists finally discovered what they had spent half a century searching for: the Higgs Boson. The ATLAS experiment, partially built at Argonne, played a crucial role in this achievement, as did Rik Yoshida, director of the lab's High Energy Physics Division. In this conversation, Rik and assistant physicist Walter Hopkins reminisce about this watershed moment, and they answer two big questions. What is the Higgs particle, and why does it matter?
So do you want to take a shot at explaining what the Higgs particle is, Walter?
In high energy physics, we have a theory that we call the standard model. It has various particles that either carry a force, say like electromagnetism. So everything you see is carried by photons, for example. It's a force carrier. And basically, every predicted particle and force carrier had been measured, the mass, the various properties, up until the Higgs. But the Higgs is very important because the Higgs essentially gives mass to all of the other particles. It really does kind of glue everything together. The reason it's special is because it's not quite the same as the other force carriers. It's a completely different mechanism of how it exists, essentially.
It's really hard to explain the Higgs particle. So maybe we should explain a little bit about what these experiments are and where they are and how big a scale they are. So they're in Geneva, Switzerland. There is a big accelerator called Large Hadron Collider, which is, I guess, about 5 miles in diameter, I believe. And there are several experiments, but two of these were built to discover the Higgs particle. So these are enormous detectors. Thousands of engineers and physicists have worked on them for actually decades to make them. And one of the culmination of that effort was 2012, when we discovered the Higgs particle. That was pretty big news. A lot of press coverage, magazine covers, science shows everywhere. So where were you when that happened?
I was actually in Chicagoland. I was a graduate student, and I was based at an experiment at Fermilab. The experiment also looked for the Higgs boson, but did not find it. The two major experiments that discovered the Higgs boson were CMS and ATLAS, and my graduate school was a member of CMS. CMS is an acronym that stands for Compact Muon Solenoid. I don't think that's very enlightening. But what it means is it has a magnet that is very strong and compact. It's a small experiment compared to the other experiment called the ATLAS experiment.
So I was pretty deeply involved in the ATLAS experiment. And Argonne has been a member of ATLAS since really the beginning. And Argonne built actually large chunks of that detector. So a lot of it was actually built not so far from where I'm sitting now in my office. And, that was all flown to Geneva and installed, and those things were running at that time. My particular role in it was essentially overseeing the discovery as it went along. So there are 3,000 people, but in the end, there is a team of people who's looking at this particular thing, the Higgs particle. And as they do that, they need some other people to look over their shoulders and make sure that what's going on is being done correctly. And in the end, to actually bring that into a publication. That was the part that I was playing. And so I had a sort of a ringside seat on the discovery of the Higgs. So I was probably among maybe 24 people in the world who had that experience, where we actually saw the thing as it was being discovered. So that was quite a highlight for me. And I think that's probably the one and only time in my career where we can actually say that I took part in a real discovery. We measure new things, right, all the time. But something really new like that happening, I think, has not happened before in my career and has not happened since. So it was really quite a big thing. So when it was discovered, were you anticipating a discovery? Did you think that was going to happen? It was everywhere, certainly in the physics world. that this is coming, right?
So initially, since I was not part of either of the experiments, I didn't know. But if I'm honest, I was kind of in the camp that was hoping that there would not be a discovery, because that would be potentially even more groundbreaking. It would mean that the theory that we have proven over and over again with experiments has a big missing hole, which is the Higgs boson. But then as the experiments started finalizing the analyses, we're not supposed to talk to members outside of the experiment. But, I sat next to a professor and he was reviewing something and I'm like, okay, that looks like...
it looks suspiciously like a little peak where the
Exactly, yeah. That looks like a very large peak. Yeah. And then we discussed it.
Yeah. I understand what you're saying when you say you had hoped maybe it won't be discovered, because if it hadn't been discovered, then it would have meant that something else was going on. That's always exciting for us physicists to figure out that what we always thought was true isn't really true, and it's something else, right? It's like a mystery novel when you get to that stage where there's that reveal where it turns out that everything that you understood up to now is actually not correct, or it's incomplete, right? And that's very exciting for us.
Non-discoveries are not necessarily disappointing. Non-discovery of anything at the Large Hadron Collider that isn't the standard model, that may mean that all the ways we theoretically predicted things that explain why the Higgs mass is what it is, our methods may be completely wrong, and maybe theoretical physicists need completely new ways of thinking, and maybe we need to find new ways as experimentalists to search for something beyond the standard model.
Why are we doing this? What is the good thing that happens when something like this is discovered? I think the answer is that, what we learn out of this is not going to help us do something in the near future. We do make progress on the way to discovering these things. But the point about understanding the world is that it takes a long time until things become useful. So let's say that if you want to communicate fast with another group of people, you might think that, what we do is we set up a horse relay. We have rested horses along the way and the rider can change and it'll be fast. Now you can do that just by knowing how horses work. But if you want to build something like the network we have today, then we need to understand lots of things, including quantum mechanics and lots of very, very complicated physics. And you would not have known that such a thing is possible if people had not actually gone off and tried to figure out what's going on in the quantum realm. And you could have asked exactly the same questions at that time. Why are you looking at this? I mean, it's all very interesting, but what is it good for? Now, nobody could have said at that time, this is going to lead to your iPhone, but it did. And I think that is the point about these kind of fundamental research. It actually allows you to understand the possibilities. Now, making this discovery also means that we have to actually make a lot of technological progress in order to do this. So there are also spin-offs. For instance, CERN, where LHC is, this is where the World Wide Web was born. And that technology was born because high-energy physicists were trying to figure out how to communicate among each other across the world. And so I think that's the reason that I think it's vital to actually keep doing things like this. And for us physicists, of course, this is a passion. We want to know what's on the next page in the mystery novel, actually. So that is what motivates us. But I think that in the end actually will bring big changes to the world.
Argonne Voices is an oral history project, recording the stories behind decades of world-changing science at the laboratory. To learn more about Argonne's 75th anniversary, visit anl.gov.